Hey guys, so recently I got myself the Raspberry Pi 4 Model B with 8GB RAM. The one I got was a starter kit from Labist that comes with Raspbian OS pre-installed and a bunch of cool accessories. You can check out my other video in the link below where I did the unboxing and setting up of the Raspberry Pi. So this is how it looks like after you set up the whole thing. It's a cool little box with a lot of interfaces. And it's really small, like palm size. So I wanted to learn about how it can be used to create some interesting project that I've seen online. There's really so much information out there that it seems a bit overwhelming to me. As I've never used a Raspberry Pi before, I don't really know how it works. So I did a bit of research and found out that for most projects you will need additional parts and electronic components. So at this current moment, I don't really know what project I want to start with, and I don't have the knowledge to actually make any project. So I went and got this. It's a Freenove Ultimate Starter Kit for Raspberry Pi 4. It comes with a whole lot of electronic and parts that you can follow through and teach yourself some coding and learn about the various functions that the Raspberry can do. There's a tutorial provided that you can follow through to. So in this series of video, I'm going to go through each chapter provided in the tutorial from the kit. And let's see, by the end of the series, will I be able to learn how to use a Raspberry Pi and probably learn some coding and how electronic part works with the Raspberry Pi along the way. Let's get started. In the tutorial chapter 1 called LED, the first project is named Blink. So this involves the Raspberry Pi as a controller using an interface called the GPIO extension board to control LED light to turn on and off. So the component needed in this project is the Raspberry Pi, a ribbon cable, a GPIO extension board, a breadboard, a 220 ohm resistor, a red LED, 2 short jumper wire and 2 slightly long jumper wires. So the slightly long jumper wire is actually for the Raspberry Pi fan. Okay, so if you see here on the Raspberry Pi, there's 2 rows of pin that can be extended out by using this ribbon cable to the extension board. The extension board is not entirely necessary, but it's a lot easier to work with on the breadboard. So if you look here closely on the extension board, you can actually see some naming that is printed on it. So the naming is not the same as the one that we are using on the coding. So I have got this reference that I've printed out on this website, pinout.xyz, which is shown here. So I'll be using this as a reference for my coding later. So before starting off with the wiring portion, I drew up a simple electrical wiring diagram for easier referencing. So this is how it looks like and how it should be wired. So if you look here, the GPIO 17 portion will be the one that we'll be using to send our output, and the resistor here, which is a 220 ohm resistor, will come next, and then the red LED, and everything should go back to the ground. So let's start the wiring based on the wiring diagram. So the red jumper wire will go to GPIO pin 17, which is this slot here, and you connect it to this slot here. So next will be the 220 ohm resistor. Use this slot over here, connecting to the next pin, and then the red LED will be connected next. So if you look closely, the red LED has 2 pins. One is a longer pin and the other is a shorter pin. The longer pin is the positive side and the shorter pin is the negative side. So make sure you're connecting the longer pin to the resistor, and the shorter pin will go back to the ground. So now I use the black jumper wire to connect back to the ground. So a closer look of how the wiring is done. And next I'll rewire the fan for powering. The red will use the red jumper wire, which will goes to the 5V here, and the black, using the black jumper wire, will goes to the ground. So that should give us power to the fan to cool the Raspberry Pi. So all the wiring is done. Just make sure everything is connected properly. And next, we will connect the ribbon cable back to the Raspberry Pi. So if you look closely here, it's actually a slot, a protruding slot here, which is just nice for you to push it into the slot here at the extension board. So if you align it properly, it should slot right in like that. And make sure it's connected all the way in. Alright, it's done. Next, we'll connect it to the Raspberry Pi. So if you angle the pin properly, it should go in nicely. I hope I don't damage anything. So let's make sure everything is connected nicely. And we'll power up the Raspberry Pi. And the fan is running, so most likely the wiring is correct. So now the wiring is done, we'll start off with the coding. I'm going to remote connect to my Raspberry Pi. Just make sure that you guys can see what I'm doing on the remote desktop. Alright, now we are logged into the Raspbian OS. We'll start the coding part. There is 2 codes for the Blink project already provided in the file that I downloaded from the Freenove website. One is in Python and the other one is in C. So I'm going to use the Python one, and I'll need the Python software to do the coding. There is a free Python IDE called Tony installed in the Raspbian OS, so I'll be using it for my coding purpose. Tony is found under here when you click on the Raspberry logo. The drop down box will appear. Go to programming and you should see Tony Python IDE. You should click on it and an untitled window should appear. From here you can start to do the coding for the Blink project. So the first part of the code is to import 2 modules into our Blink program. I think of modules as different programs that were pre-created by other users or Python developers. The first module will be this Raspberry Pi.gpio. So there's a simpler explanation in the tutorial provided. I extracted out this portion and it says this. This is a Python module to control the GPIO on the Raspberry Pi. It includes basic output function and input function of a GPIO and function used to generate the PWM. So basically this is the Python way to control the GPIO on the Raspberry Pi. And the next module that we will be importing in will be this module called time, which will have a delay function which we'll be using later. Next is to define the pin that we'll be using. It will be called LED pin. And we'll give it a value 11, which is used to correspond to the number on the pin, where you can see here from the pin layout from our referencing table earlier. So the next part is where we define the functions to be used in the program itself. I think of function also as individual programs that contain a block of codes, but it's written in the program itself, which will be called upon to be used when required. The first function is called setup. This is where we set up the pin parameters, and the code goes like this. DEF is the statement to use to define a function, and the name of the function is called setup, and the semicolon will indicate the beginning of the code. So the first line is GPIO.setMode GPIO.board. So this first line, GPIO.setMode, is where we tell the board what kind of numbering to be used. We'll be using the physical GPIO numbering. So for this set of numbering, we will use the mode GPIO.board. So the next line is where we define if the pin is an input or an output. Setup LED pin GPIO.out. So if you notice here, this GPIO setup, there is two parameters, one called LED pin and the other one is called GPIO.out. So for this project, because we are using it as an output point, as it will be sending out a command to tell the LED to light up, so it will be an output point. So the first parameter, LED pin, actually tells the GPIO what pin is actually an output. So LED pin here refers to 11 and GPIO.out means that it is an output. And the next line is where we define the pin initial status. GPIO.output LED pin GPIO.load. So same here, there's actually two parameters in this .output function. The first is the same, which is to define what pin to use, and the other one is actually to tell what is the output to be sent out. So currently we are using low, which means to turn off the LED. So the next we'll be using this statement called print. And the open apostrophe will be the message that we want to print out. So basically this line is a print statement which will print a message saying using pin %d. %d is actually like a placeholder which will pull out the number within the LED pin and place it in the message. So basically the message will read this, using pin 11. And we are done with the first function. So next we'll be defining another function called loop. This is the part where the program will keep running until some additional command is given. So def and the function name loop and semicolon to indicate the beginning of the block of code. So to make sure it is a loop function, we use this statement called while true. So this while true statement basically just keep looping the block of code within it. So the first line for the loop is actually the code to turn on the LED, which will be GPIO.output. Define the pin, which is LED pin, and to tell the LED to light up, which is GPIO.hide. So remember that low means turning it off and high means turning on the LED. So next we'll give an indication that the LED has turned on. We'll print a statement saying the LED turned on. A few arrows, close the bracket, and then next we'll give it a delay of 1 second, which will invoke the time module, which is time.sleep, a 1 second delay, and we're done with that. The next what we're going to do is to turn off the LED. So the function for that is GPIO.output. Define the pin and .low to tell it to turn off. So the same thing we'll do here, which is to print another statement to actually tell whoever the user that the LED is turned off. So LED turn off. And we're done with this print message, and just like the same, we'll give it another delay of 1 second, and basically we are done with this functions. So now we'll define the last function. Def destroy. This last function is called destroy. Sounds like something devastating, but it's actually just a code to ensure the GPIO pins are set back to its default setting. and the statement is gpio cleanup. It's just a one-line function, and we are done with defining of all the functions. So the next is where the main program is. We will use this statement, if underscore name underscore equals to underscore main underscore main. This is basically a statement where if you enter the name of the file, the Python program will start to run. So once the program starts running, the next line it's an indication to tell you that actually the program is running. So for that, we use a print, and the message that we are going to use is program is starting. Make it go to the next line, and that will be the message to tell that the program is running. So next line is where we will call the setup function that we created earlier to run, which is to set up the GPIO pin 17. So for that, we'll use this setup. So if you remember, this setup, open and close bracket, we'll be calling this particular portion of the statement of this function and this block of code to run. And next, we'll use this statement called try, which goes with this accept statement. Try. Accept. So basically it means try and perform this block of code over here, and if something happens, perform the other block of code in the accept block. So in the try block, the code that we'll run is actually to use the loop function, which is over here, which is to turn the LED on, a delay, and off, and then a delay. So for the accept part, we'll be using this statement called keyboard interrupt. So basically what this means is when you press on Ctrl C, you actually cause the loop here to stop, and you will goes on to this particular block of code, which we'll use is destroy, which means to clean up. So once you are out of this loop, basically it is the end of the program. So basically all the coding is done, and let's check through. We'll save our file and name it link. Okay, and our file is saved. So now we can try to run the code, and let me set up the camera. I think this should be a good zoom, and we'll run the code. Fingers crossed. We have an error. Name error, name LED pin is not defined. Line 8. Line 8. Pin. Oh, we have a typo here. So the Python is case sensitive, so just make sure that all the letters is actually in the correct case. And let's run again. Great. So basically, it show here program is starting using pin 11, LED turn on, off, turn on, and turn off. Alright, looks like our program is running. So now I will press the Ctrl C to invoke the destroy function, and Ctrl C, and the LED stop blinking. So it works. Great. Alright, since now we are in the Python IDE, I'll try to use the terminal and also to try out the program. So I'll stop, it's already stopped. I'll quit the IDE, open up the terminal, and navigate to my Python folder, which is this Python, and the program is saved here called Bling. I'll use the Python application, Python, and use type bling.py. This will run my Bling program. So program is starting using pin 11. LED is turned on and turned off, turn on and turn off. All right, I got my program working. So same thing, I'll press on the Ctrl C to invoke the destroy function, which is to stop the program. Ctrl C, and we are done. All right, great. I hope you guys liked the video, and do leave me a comment below, and I hope to see you in the next series. All right, see you.